Alright, in this next section, 8.3, we're going to be talking about determinants of matrices and how we can use them to solve systems of equations. Now, a determinant is a special number that is associated with any square matrix. Okay, so a square matrix, first of all, let's define a couple things. A square matrix has the same number of rows and columns. Has the same number of rows and columns. So when we do the R by C or the row by column, it's going to be the same. So for instance, a 2 by 2 or a 3 by 3 or a 4 by 4, etc. Those are your square matrices. Now, all square matrices have a determinant. And we are going to learn how to calculate those for the 2 by 2 and the 3 by 3 case. There is a method for calculating determinants for all cases that generalizes to all cases, but the techniques I'm going to show you for the 2 by 2 and the 3 by 3 cases are not ones that you can generalize to others, but I believe they are quicker and really all that is necessary for us to learn how to solve the systems that we're going to be dealing with. If you want to learn how to do the more general ones, you can go through the textbook or ask me questions, I suppose, and you could get some of that information or look it up online as well. But right now, there's a trick that I'm going to show you for 2 by 2 and 3 by 3 matrices to find the determinants. Okay, so let's take a 2 by 2 matrix in general. So, generally speaking, we would have, if we did a, well, that was weird, that was my furnace going off. I don't know if you caught that in the video. Weird sounds. Anyway, you get a 2 by 2 matrix here. A general 2 by 2 matrix, we'll call it A, B, C, and D. Okay, the notation for a determinant can either be written as DET in front of that matrix, A, B, C, D. Now the A, B, C, D are just numbers. I'm using letters because it could be anything. Or you could write it as, instead of the determinant DET in front, some people write it with, kind of looks like an absolute value. It's not an absolute value, but it looks like it's just two vertical bars on either side. Your textbook uses the vertical bars, okay, rather than this determinant notation. So I will be consistent and use that notation as well. So this, when you see just a straight vertical bars, that represents a determinant. If you see the brackets, that's the matrix itself. So with a 2 by 2, the determinant of A, B, C, D is defined to be AD minus BC. It's just that combination of numbers. And so the way that I remember doing this, or the way that I remember this, is to multiply the diagonal numbers going down to the right. You multiply those and you get the AD, and then you multiply the diagonal going up to the right and you get the BC, right, or CB, whatever order, doesn't matter. And then you take the bottom one minus the top, right, bottom minus the top. Okay, that's it. That's simple. And for every 2 by 2 matrix, this will give us a number. So for instance, just a basic one, we did the matrix 1, 2, 3, 4. And look at its determinant. Well, you do that diagonal going down, you get 1 times 4 minus the diagonal going up, which is 3 times 2. Okay, and when we calculate that, it's 4 minus 6, which is negative 2. Right? And we can do this with any 2 by 2 matrix. Again, negative 3, 5, I'm just making something up on the fly here, 4, and negative 6. Again, I'm going to go ahead and just do these on the diagonal. So if you do the AD part first, that negative and negative make a positive, that's 18. If you do the BC part next, that's a 20. And of course you do bottom minus the top, so the answer would be 18 minus 20, which again is negative 2. Interesting. I didn't plan that. Okay, so that's it. That's how you calculate 2 by 2 determinant.